I've been looking at this integral for a little bit here before I made this video, and I was trying to decide what method would be best to use with it. Well, we just don't have a whole lot of options. U substitution won't work because the derivative of x squared is x, and we don't have an extra x lying around here to use. Parts, there's not a product of two functions there, so that won't work. We could try partial fractions, but the denominator doesn't factor. So our only other options are trig substitution and tables, but we're going to do trig substitution just because it's harder, and we all need the experience with it. So the first thing to do with trig substitution is to complete the square here. So I take x squared plus 4x plus, and siphon off the 5. Take this middle guy, divide by 2, and square him. And he goes back in here as plus 4, but I have to subtract off 4 in order to maintain balance and make sure that this expression is equal to this expression. So this first quantity here I can factor to x plus 2 squared, which is what I'm looking for. That means I put in a number here to complete this line so it's a perfect square, completing the square. 5 minus 4 is 1. So I can rewrite my integral as 1 divided by x plus 2 squared plus 1 dx. Now, if I'm going to do a trig substitution, I have two choices. Well, there's three choices, but we're only going to have two choices. You're either going to be using sine or tangent. And the one you choose is dependent upon what sign this is. Since I know that tangent squared plus 1 is secant squared, I'm going to use tangent to be my substitution. But I'm going to let x plus 2 be tangent t, because I want this whole thing to be tangent t. I want tangent squared plus 1, not tangent plus 2 quantity squared plus 1. So I let that whole interior thing be the tangent. Taking the derivative of both sides, I get dx equals secant squared t, dt. Now doing the substitution, 1 over the whole quantity x plus 2 becomes tangent t plus 1. Dx becomes secant squared t dt. So secant squared t dt. Now, because I remember my trigs very well, which you should always remember, the numerator stays the same, but the denominator, if I have tangent squared plus 1, that's an identity where I can rewrite that as secant squared t. Now, that's beautiful. Secant squared divided by secant squared is 1. The integral of 1 dt is t plus c. Yay! Now you think you're done. The only problem is I started in the variable x and I ended in the variable t, and I'm not supposed to. I'm supposed to end in the variable x. So I go back up and look at this and I say, okay, well, I can solve for t pretty easily with that. So take the arctangent or the tangent inverse of both sides, and I have arctan of x plus 2 equals t. And so over here I substitute arctan of x plus 2 and plus c, and I'm done then. The only reason why I use arctan instead of tan inverse, by the way, this is just FYI, is because this little symbol here often gets lost in the mess of doing a problem. So I just use arctan and it makes it easier.